I talked about mid equals to start plus end minus start by 2. Now, what does this mean? Let's look at this. So let's look at two things. I will be stating start as S and end as E. Okay. So how do we find mid in general? We do start plus end by 2. This is what we do, right? Everyone agrees with me on this. This is what we do. Now, suddenly, what I did start minus. Exactly, right. So here what we do, start minus, start plus end minus start by 2. This is what I wrote here, right? In this particular code, this is what I wrote, start plus end minus start by 2, right? So now, why did I went into this trouble of writing this? Okay, because if everything was already working on this particular scenario, then I shouldn't have gone to, making it complex, because if I open this up, how will this look like? S plus E by 2 minus S by 2. Now, what is S minus S by 2? Basically, S minus its half. That's S by 2. And plus E by 2. Now, just do S plus E and the by 2 comes below. Is the same thing, right? This thing and this right here, which I wrote, they are the same thing. Make sense? Then why did I go into this much trouble of doing this? So see, this is something for Java and C++ peeps. For Python people, you don't have to worry about it, because Python does not have the concept of int, long, and all that. Whichever you write, Python will, take care of it. So this is not something you guys have to care. Like, you guys can always write S plus E by 2 and you can get away with it. But for Java and C++ people, what happens is your start, end, and mid, everything is an int, right? How much does an integer, how much data can an integer hold? 4 bytes, right? How much is 4 bytes? 32 bits, right? 1 byte is equal to 8 bit. So 32 bits. What does 32 bits mean? How much data can it store? Basically 2 to the power 32 minus 1, I think. Yeah. That is the amount of data that it can hold. Basically, this is not important right now. The point is that it can only store till 2 billion. If you are considering both positive and negative, 2 billion. If you are only considering positive, that is, you are not taking the negative values, then that's 4 billion. Not important for this session. The point is, the only thing that you should take away from this is an integer can only hold 2 billion. Like, after 2 billion, say if you want to store 3 billion in a integer value, Java and C++ will throw a garbage error. Okay. It will assign a value, which is, not very like it will return a very ugly value, which you won't like to see. And I will show you how that value looks like. But now, let's say you have two values. Okay. Let's say you have 1.5 billion. And one place you have 1 billion. Okay. So say this is your end value and this is your start value. Okay. You have been given these two values. So let's draw a line to understand this. This is your start. This is your end. You want to search for mid, the middle element, right? The middle element should lie somewhere between S and E. So now, what do you do generally? You do S plus E, right? You do this S plus E. How much S plus E means? That means 2.5 billion, right? That's greater than what an integer can hold. So in that case, so this is basically the int max line. Okay. This is the int max line. That is the maximum integer that Java or C++ or any basically the computer can hold. Okay. And S plus E, this was at 2 billion. And S plus E, this S plus E lies in this side of the area, 2.5 billion. It cannot. So this is basically like, basically I'm giving you some of the, things on your hand. Okay. I give you, say, thing number 1, then stuff number 2, stuff number 3, stuff number 4. At first, you will be able to store those in your palm of your hand. But if I keep giving you, for example, I put 10 things on your hand, they will start to fall off and everything will look messed up. Same thing happens here. You do S plus E, you reach at a position where you don't want to be, and it will throw you an error. No, sorry, not an error. It will just store the value. Like you're calculating mid, right? Mid will contain a garbage value. It won't contain the actual value. And in this case, mid should have contained an actual value because mid lies between S and E. So mid has a value somewhat like 1.25 billion. An integer can hold that. But due to our overflow issue, we were, since we added S and E, it went on the overflow side. So that's why, what do we do? What is the formula that I am using? I'm using S plus E minus S by 2, right? So let's look at how this will, pop up in the chart. E minus S. E minus S will lie somewhere here. You agree with me, right? E minus S should lie somewhere here. Divided by 2. If I divide that number by 2, it will lie somewhere here. It will basically, by somewhere here, I mean between S and E. It will always lie between S and E, right? And then if I add S to this particular number, I will reach somewhere here, which is my mid. So in this case, I always stay within the range of S and E. I don't go in the overflow side. That's why we use this S plus E minus S by 2. I can show you an example. This is a sort of a small assignment for you. Just do this. Where did it go? Just take int low is equal to this number and int high is equal to this number. Okay. For Java and C++. For Python, you guys can. In fact, yeah, do this. Do this. For Python, you won't see this, weird behavior. When you do mid is equal to low plus high by 2 and then print mid, you will see that the output is something like this, negative 88850, something like that. That's a garbage value. That is not a value that you were expecting. You were expecting this value, 12589, something like that. And similarly, if you do mid is equal to this and then print mid, you will get this particular value, the right value. So this is one small assignment for you, not even an assignment, a small task, like trivia task. Just do it in your editors and, check out what the result is. So this is one thing that I wanted to tell you, that what low plus high minus low by 2 represents. But see, again, with all of these things being said, one thing to keep in mind is that whenever you are sitting in an interview, the values that you will generally get will range between 10 to the power 5 and 10 to the power 4. Basically, this is the range where lead code plays. Lead code, the constraint of lead code always remain between 10 to the power 4 or 10 to the power 5. Okay. So for that, your condition low plus high by 2 should work. And it should work also in an interview. So probably no one will, point you for that, but this is a good thing to know. Okay. And I'm pretty sure, like some of you might have raised the question that why this has been written in the upcoming lectures. So I just wanted to clarify this. One more thing that I've